It's just going to be a quick video to help us with the next test. So, a couple of questions from your sheet that you were given. The first one was factorise 14z plus 21pz plus 28z squared. Now when we're factorising, we're looking for something that is common in each term. The terms are things separated by plus and minus the sign. So we're looking for something common to 14z, 21pz and 28z squared. Now if you look, firstly you can see that there's z's are common. Alright, they each have z in it. This one has two z's in it, this term has two z's, but they each have at least one z. So we can write z out the front. Alright, and then we're going to put a bracket. Now if you look closely, you can also see, look and see if there's anything in common between the numbers, between 14, 21 and 28. And if you start at 7, and then add 7 to that and go 14, 7 to that, go 21, 28, you'll notice that 14, 21 and 28 are all multiples of 7. So that means that if you like, instead of writing 14z plus 21pz plus 28z squared, we could have written 2 times 7z plus 3 times 7pz, that's 21, plus 4 times 7z squared, because there's 2 lots of 7 in 14, there's 3 lots in 21, and there's 4 lots in 28. So we can also take 7 out the front. Oops. So we can also take 7 out the front. And then we've got to think, what do we get left with once we take 7 out the front? So we get 7z. What do we get left with? Well, here, look down here. We'll get left with 2 here, 3 here, and 4 with 1z because you've got z squared. Now, if you don't want to think of it like this and don't want to write this out, and you really don't have to, you can go, okay, I recognize that 7 is a common multiple of 14, 21, and 28. What do I need to multiply 7z by to make it equal 14z? And the answer to that is just 2. You need to multiply 7 by 2. So 2 is going to go in there. Then you go, what do I need to multiply 7z by to make it equal 21pz? The answer is, well, 7 times 3 is 21. And of course I need a p because I don't have a p. And then what do I need to multiply 7z by to make it equal 28z squared? Well, there's 7 times 4 is 28, so it's going to be 4. And then I've got 1z outside, I need 1z in the inside. And so the answer is 7z outside of 2 plus 3p plus 4z. So if you just put a z out, you're sort of right, but you're not completely there. You've got to also look and see if there's anything common between these numbers. And writing out like this might help. Now this question over here, if it says simplified out, you can't really factorize it because there's nothing in common between each of these terms, all right? And they're the only thing that are separated by a plus or minus sign. These are multiplied together. 5 plus x is multiplied, 5 plus x, that whole thing is multiplied by that. Alright, so they're not actually terms because they're multiplied together. So, when we have something like this, we've got something over something, first thing it's really good to do is look, is there something in common between the top line and the bottom line? And you'll see that 7 take x on the top line and it's also on the bottom line. So you can just cancel those. Now when we're cancelling it, we're not really just getting rid of it. That means 1, because what we're really doing is 7 take x divided by 7 take x on the bottom and the same on the top. So you get left with 5 plus x times 1 over 1, which is just 5 plus x. So that's the answer to this. Now, again, if you get simplify for this one, to do this, you don't have the nice thing over here where you've got something on the bottom that you can just cancel on the top. Alright? You might go, oh, I've got z's on the bottom and y's on the bottom, and I've also got z's and y's on the top, but you can't just cancel them away until you factorize it first. So the first step always is to factorize, all right? So factorize the numerator and the denominator. So we're going to factorize the numerator by taking out a common factor. What is common to zk and yk? Well, it's obviously k. K is common to both of those. So we're going to put k at the front. And that's going to become k outside of 7, z take y. Then pz and py, what's common to that? Again, p is common to that. So it's going to be p outside of z take y. Now you'll notice, if we put our equal sign there, you'll notice that z take y is common to the bottom line and the top line. So we can just cancel those and we get left with k k over p. So that was learning intention 1. These two are sort of learning intention 2. They're two of the questions that you were given. Let's move on. Okay, let's start doing some multiplying and dividing. So I give you this one, which is again one of the examples, 12b on 2, when it comes up, 12b divided by 2 times by 2b over 4. Now when multiplying, one really interesting thing to note is that you can cancel diagonally. You can cancel up and down, but you can also cancel diagonally. So that means that I can cancel that 2 and I can cancel that 2. Alright? They're the same thing, I can cancel them. Now I can also go, does 4 go into 12? And the answer is, again, multiples 4, 8, 12, that there are 3 4s in 12. So I can cancel that 4 and that 12 becomes 3 because I'm really dividing 12 by 3. So now, remembering that that's 1 and that's 1, now that I've cancelled, that becomes 3b over 1 times b over 1, which is really equal to 3b times b. If you multiply something by itself, it becomes squared, equals 3b squared over 1, which is the same as b. Alright, let's do another one, but this time let's do, we'll do another multiplying one. So we're going to do 6 times 4e on 7. Now don't be worried by letters, they're just the same as numbers, really. 6, if you've ever got a number like that and it doesn't have a denominator, just make it 6 over 1. So that's 6 over 1 times 4e over 7. And then you can multiply those together, multiply the numerators together, because that's what you do in multiplying fractions. You multiply the numerators together, or the top lines together, and you multiply the denominators together. So you get 6 times 4e, which is 24e. 6 times 4 is 24 over 7. And 7 doesn't go into 24, so that's as simple as you can make. And there wasn't anything you could cancel, even on the diagonal. Now if we've got this one, this is 8b on 5 divided by b squared, 15. Now this is dividing. Remember, keep, change, flip. Keep, 2, change, and 3. Sorry for my writing. 3, flip. Alright, so we keep the first fraction the same. So that's going to be 8b on 5. We change the division sign to a multiplication sign, and we flip the second fraction, so it's 15 on b squared. Now, can we cancel diagonally? Yes, we can. That b gets rid of one of those b's, and that's a 5. So we go, how many 5s? We can cross that 5 out, and then we go, how many 5s are in 15? 3. Alright, so that becomes 3. So now, what do we have? Well, let's rewrite that really neatly. So we're going to get 8 times 8 over, well, we'll cross out the 5, so it's really 8 over 1 times 3 over b. Then we multiply numerators together, so that's 8 times 3 over 1 times b, and denominators together, and that equals 24 over b. So that's how we do those sort of questions. Alright. Now, the last type that I'm going to talk about in this video is addition and subtraction. So if we've got 8y on 3 plus 3y on 5, what I want you to remember is if you have a fraction like this, 8b plus a on b, so pretend a and b are numbers and c and d are numbers. So if you've ever got this and they're added together, that's going to equal ad, or a times d, plus bc, or b times c over bd. So basically you multiply the denominators together, and becomes the denominator. Then you multiply a by d, and that becomes this one up here. You multiply b by c, and that becomes that denominator here. So that's how we do these ones. We go, okay, I'm going to multiply denominators together. 3 times 5 is 15. I'm going to do 8y times 5, and that's going to be 40y, and I'm going to do 3 times 3y, which is going to be 9y. And then that's, I can just add together and make that 49y over 15, which again, it can't be reduced.